Hi, it's Brett the Lab Tech here, and I am going to show you today the demonstration for the BI112 fermentation experiment. So this first experiment, we're just going to be seeing how the system works and looking at the effects of increasing yeast concentration on the rate of fermentation. So I'm going to start setting that up. The first thing we need to do is to make a 15% yeast solution. So I've got my yeast beaker already labeled here. I've got 20 milliliters of deionized water, pre-measured. And to this, I need to add 3 grams of yeast. So I'll use the balance for that. Zero out the balance, or tare it. We'll get 3 grams of yeast in there. Go. Oh, 3 exactly. All right. Pour this into the yeast beaker and mix it up. And these yeast are dehydrated. It's basically just what you get at the grocery store. So they've been dried out for quite a while. So it's going to take them some time to reanimate and wake up and be able to do glycolysis and fermentation and aerobic cellular respiration again. So what we're going to do is let the yeast kind of sit for a while. Got a timer here. I'm gonna set it for 20 minutes. I'm not gonna make you watch and wait while the yeast are reanimating, but I'll go ahead and label the tubes and get some other things ready, and also move the camera so you can see what's happening a little bit better. So we'll let them sit for 20 minutes and I'll be back in a bit. Okay, it's been about 20 minutes here and our yeast are hopefully all woken up. Oh, there we go. Actually, we'll leave that set for our, actually no, I think we want a count up timer for the experiment. Okay, so we've got our yeast here, and we have deionized water, and we have some 20% glucose to provide some carbohydrates for those yeast to metabolize. And now we need to set up our tubes. So this is the setup that I'm going to be using. So we're going to have 3 different tubes, 0, L, and H. The 0 is no yeast, the L tube is a low amount of yeast, and the H tube is a high amount of yeast. So we need some different amounts of deionized water in these 3 tubes, and then different amounts of yeast suspension that will, between the yeast and the water, it will add up to 1,000. So effectively we're testing the effects of increasing yeast concentration in this experiment, and then the same amount of glucose in all 3. So I have our fermentation setups here, and basically what this is a little syringe that has no needle on it, but the nice thing is it has these graduated markings, and with this plunger we can get the fluid level exactly where we need it to start. And this first one I have labeled 0, so that's going to be our no yeast tube, and then I've also labeled one L and another one H. So our tubes are set. We don't need the syringes in there right now. So we'll set those aside and start measuring out the water. So the first amount of water, oh, actually I should use the right tool for this. So the first amount of water that we need was 1,000 microliters for our tube 0. And that again is just going to be deionized water. So I'm going to get 1,000 microliters there and add it to the tube. And then the second tube is, the tube L is going to get 750. So we need to reset our micropipette and get 750 microliters of water. And then tube H is going to get even less, 500 microliters of water. All right, so we have the water. Now it's time to do the yeast suspension. So I'm going to stir this a little bit more to make sure the yeast are uniformly suspended. And here I'm going to go kind of backwards because I already have the micropipetter set for 500. Microliters, and then reset it for 250. Add that in. All right. So now I'm going to leave that tip in the yeast for later. And now we need our 500 microliters of dextrose or glucose in each of those solutions. So I'm going to get a new 500 microliter tip. And just to show you, it's our new tip for the 500 microliter pipette. That did not get a good seal. I'm going to try this again. I'm going to try reseating the pipette. It was dripping on me. Oh yeah, okay. So I firmly sealed that on, so hopefully it will hold the fluid. There we go. Okay. I need to be very careful not to contaminate the glucose with the yeast, because if I do that, then eventually we're not going to have any glucose left. All right, and I'm going to discard this tip into our tip disposal bag. All right, so now we have our three solutions, so no yeast, 250 microliters of yeast in the L tube, then 500 microliters of yeast in the H tube. And you can clearly tell that these have different amounts of yeast in them. So now what we need to do is get that fluid into these fermentation chambers or syringes. And I'm gonna start with the tube 0. And what I wanna do before I start adding it is just kind of mix up the yeast a little bit. And then with this last draw, I'm going to try and get the air bubble out. So if you see that, there's a little bit of airspace between the end of the fluid and the plunger because the plunger can't get all the way to the tip. So what I'm going to do is turn this upside down and flick it try and get that air bubble up to the top. Okay, there we go. Then we'll carefully squeeze that out. So the fluid's just at the tip. Okay, and that is ready to go. I'm gonna get it maybe a little past where we need it. And then we can, so when we get to setting it up, it'll be pretty quick and easy. Okay, so I'm going to do the same with the L tube. So again, just kind of mix it up a little bit. Just by using the syringe to move that solution around. And again, I'm going to try and get the air bubble out. You don't have to do the air bubble step, but if you don't, then you will need to be careful about where this one is really hard to see, and it looks like that air bubble is not moving. Oh. I'm gonna try this again. You will need to be careful about where the fluid line is if you have an air bubble in there. So you don't want your air bubble to start counting as your data. That is just not moving. Oh, there we go. There we go. Finally got it. Okay. So it's a little bit trickier. The yeast is kind of sticky, so if you're doing this for yourself, be careful with that. Okay. And again, we'll go a little past where we need to be to make it a little easier and quicker to start the experiment. Okay, so we'll do this with the high yeast setup. And again, just move that mixture around a little bit. Make sure it's really well mixed. And of course, as these run, the yeast is going to settle out of solution a little bit, and that's okay. Actually, I'm going to do this over here so I don't make a mess on the desk. Just moving that air bubble up. Go. All right. And again, I'm going to move this up a little higher. So now I think we are done with the setup, and we can set the timer to start going, but I'm actually not going to set it quite yet. I'm going to adjust these so that the plunger is right at the start. Okay. Get that right to the 0 mark. There's the tiniest little bit of an air bubble in there, but we can safely ignore that. And this one is a little bit higher, a bit down to the 0 mark. And this one was actually a little bit low, so we'll move it a little bit high, set it to the 0 mark. And now we are good to go. So we'll start the timer. And basically every 5 minutes, we're going to record where the fluid level is inside each fermentation chamber. And doing that will allow us to see how much fermentation has happened. So I'm not going to make you wait these 5 minutes. My lab assistant and I will keep a close eye on this, and we'll see you in a few minutes. Okay, it is the 5-minute mark, so we're going to read each of these. This is tube 0, and you can see that it has not really moved. There's no like air bubbles stuck in here. Just for good measure, I'm going to flick the syringe just in case, because we want to treat everything equally. And then tube L, we will do the same thing there, right? We'll flick that syringe. Actually, here, do this over the thing just in case anything leaks out when we do this. And that looks like it's still at 0. Okay, and then tube H. Do the same, and I realize we're now at about 6 minutes, but I'll try and be a little quicker next time, but that one is still at 0, so still getting started. Which is kind of as expected. The yeast actually maybe needs more than 20 minutes to get going. So we'll go ahead and record this data on our data sheet, and we shall see in another 5 minutes if anything's happened. All right, we're coming up on the 10-minute mark, so now we're gonna take another look. Realize now it's a little bit before time, but you can still see in tube 0, there's nothing going on there. So no air bubbles in tube L. Once again, oh, let's flick that one, and then we'll flick this one to try and dislodge any potential carbon dioxide bubbles, and it looks like that is still reading 0 as near as I can tell. Okay, and then for tube H, again, we'll flick that. And read that. That looks like it is still 0. So not seeing anything there. All right, so we'll wait another 5 minutes. Okay, we are at 15 minutes, and time to do the flick and measure again. So that tube 0 is still at the 0 mark. Tube L is still at the 0 mark. And then tube H still at the 0 mark. Will anything happen in the last 5 minutes of the experiment? Tune in to find out. So we'll pause this and see you in 5 minutes or less. All right, we are at the 20-minute mark now, and something unfortunate has happened. No fermentation. So I think our yeast weren't quite ready to ferment. Might have been a little bit cold in this room. But yeah, our tube 0 is at 0, which is maybe not too surprising. Our tube L, we'll just make sure there aren't any air bubbles. I shouldn't say air, it's most likely carbon dioxide if there are any bubbles there, but I don't see any that were stuck to the side and now have floated to the top, so I think that is still at 0. And then tube H, I'll do the same thing and then measure. That one is maybe just starting to get some. So we will call this experiment not a success, but actually what I think I'm going to do is I'm going to keep running these. I'll run them for another 20 minutes and take some more data, and maybe the fermentation will have started by then. Okay, we are at the continuation or rerun of this experiment, depending on how you want to look at it. So before I take the readings, I'm going to flick all of the fermentation tubes just to kind of dislodge any air bubbles that might be stuck to the sides. And now we will go ahead and read them. So here is tube 0, There is no fermentation there. So that is at the 0.00 mark. Tube L, there's a little bit there. So I'm gonna say 0.02. There's a little bit of airspace there at the top. So 0.02 for tube L, and for tube H, oh, it's hard to see. It's so hard to see. We'll call that, I'm gonna say 0.03 for tube H. And we will wait another 5 minutes after I record the data here, or actually really another 4 minutes. So we'll pause it and wait. All right, we are coming up on the 10-minute mark. So again, we'll flick our tubes. Just dislodge any CO2 bubbles and read the tube 0 is still at 0. Okay. Tube L looks like it is 0.05 now. It might be a little hard to see, but maybe tap that a little more. But, 0.5 for tube L, and then tube H. Wow, this is really going. So it is at 0.1, as near as I can tell, 0.15. Again, I'm going to record those numbers before I forget them, and we'll see you in 5 minutes or 4 minutes or whenever. I should note that, what was I going to say? Oh, the readings of these are kind of backwards, so I'm kind of mentally subtracting the actual number, which would be 0.85 for tube H here, from the starting value, which was 1.0, or vice versa. So yeah, subtracting the smaller number from the bigger one to give us our reading. But I'm doing that mentally, and really I'm just counting the each big division would be 0.1, each medium division would be 0.05, and each small division would be 0.01. So that's how to read those tubes. All right, so we will wait and see you in a few minutes. Okay, it's time for another measurement. So we will once again tap each tube, dislodge air bubbles, and then read them. So tube 0, we are still reading 0. There's maybe like the tiniest little bit of an air bubble there, and maybe that's from slightly over vigorous tapping, but we'll round down to 0. Okay, for tube L, looks like we are at 0.07, or maybe 0.08. Actually, I'm going to say 0.08 for tube L. And for tube H, we are, all the way down there at 0.26. And again, we'll record all those numbers and take our final readings in 5 minutes or less. Okay, we are at 20 minutes, and my lab assistant here has picked the winner, but let's collect the data. Again, tap all of them uniformly. Okay. Tube 0, the final reading is, as near as I can tell, 0. So, all right, that was tube 0. Record that data. Tube L. The final reading there looks like, I'm gonna say 0.10. And tube H, that looks like the final reading is 0.36. I'm gonna say, yeah, I'm gonna say 0.36. Our final reading. So here is our data. We can go ahead and stop the timer. It turns out the yeast takes a little longer to get going, so maybe, a good 30 or 40 minutes would be better to let the yeast reanimate. So we learned some things there. And this is our data. So as we can see, tube 0 with no yeast, there was no fermentation, no CO2 bubbles, or no gas bubbles. We aren't 100% sure it's CO2, but that's our most reasonable guess without measuring it. Tube L had a fairly low rate of fermentation, so just 0.10 milliliters over the 20 minutes of fermentation. So you can divide 0.10 divided by 20 to get the rate of fermentation because we started at 0. And then for tube H, the high yeast concentration, that fermented 0.36 milliliters of CO2 in that 20 minutes. So obviously a much higher rate of fermentation. And again, I'll leave the calculation of that rate up to you. So there we have it. Successful experiment. Thank you, lab assistant. And we will move on to the independent experiments, looking at different factors that might affect the rate of fermentation.